Do you recall how in the previous video we identified 3 main reasons why applying blockchain to the energy market makes sense? Those reasons were improving flexibility and liquidity, enabling automated settlements, and reducing the number of intermediaries involved. Not sure if you remember? You can revisit that episode. Today, we will examine 2 key aspects of tracing the energy supply chain, both of which blockchain can support effectively. Now consider this. What do whiskey, vaccines, luxury bags, and organic food all have in common? We want them to be authentic, genuine, not counterfeit, and consistent with the claims of the producers and sellers. We want assurance that what we drink, eat, wear, or inject is exactly what it's supposed to be. As consumers become increasingly aware, this demand for authenticity grows stronger, especially in an age where greenwashing and false advertising are widespread. This pressure encourages consumers, producers, and retailers alike to search for dependable methods of tracking where goods come from and how they move through the supply chain. The same logic applies to energy. But who would want to counterfeit energy? And why should we care about tracing its journey? There are 2 major reasons. Firstly, verification of the energy source is needed when presenting the source, geographically and what resources it uses. It gives clients and customers certainty about energy being green or, for example, not from sanctioned areas, like Russian coal. It gives energy providers material for their ESG reports. Secondly, verification of the infrastructure and its elements' operational usage. This is a way to easily track transformer wear, maintenance needs, and share information about technical aspects of physical infrastructure. Let's take a closer look at both use cases. Starting from energy source tracing. How does it work? Sensors capture data. IoT meters at producer sites record energy type, timestamp, volume, and location. Sometimes it's a semi-automatic process. QR codes are scanned or data blanks are filled by data import. And it all goes into the blockchain. No, that would be a really inefficient implementation. So expensive and slow and not at all environmentally friendly. Instead, the data is first sent securely to an ingestion layer, a middle layer that processes it before anything reaches the blockchain. Off-chain middleware services group the incoming readings. That's definitely a great place for preliminary quality checks to ensure data integrity, range checks, duplicate filtering. Now we go on-chain. Validated data batches are usually hashed and sent into the blockchain. Let's assume we will focus on electricity and use smart contracts to store source ID, generation time, generation volume, location, and the mentioned data hash. More data, and especially any personal information, is now kept off-chain. For example, why can't we put the name of the responsible employee even hashed on the blockchain? That's a bigger topic, and I talk about it in another video. If you would like to watch it, the link will appear in the upper right corner. Getting back to tracing the source of electricity. The dataset in the database is linked to the blockchain ID. Different systems and companies can follow this path by sharing their energy flow data and parameters. With a strong backend and reliable dataset in place, it's time to think about how to use this data effectively. One way to unlock value is by building a web application. This app should include clear data visualizations, easy-to-use search tools, and support for both off-chain and on-chain layers. Users will rely on the system for audits, regulatory reporting, and calculating statistics. Some data providers may want to integrate the data directly into their own systems, so offering access through an API is essential. Each unit of energy can be tracked. This ensures that sustainability claims are backed by real data, reducing the risk of greenwashing. That's one of the paths to a blockchain-based tracking system. It's time for a reality check. Has anyone in the energy sector actually tried this out? The answer is yes. For example, Iberdrola, an electric utility company focused on offshore wind, partnered with the Energy Web Foundation to launch a project in Spain. Customers in Madrid, Bilbao, and several other cities could verify the origin of their electricity and confirm that it came from renewable energy farms. At Espeo Software, we prepared a system for the digital climate group that, with the help of AI and blockchain, provides proof of green energy sources for investors. The system included regulatory reporting features as well. Energy source tracking is one way to operationalize data. The second one, mentioned at the beginning of this video, is something I would call decentralized maintenance.